Projectile motion is a form of motion in which an object or particle, called a projectile, is thrown near the Earth's surface and it moves along a curved path under the action of gravity only.
An object shot through the air is called a projectile. After a projectile is launched, what forces are exerted on the projectile? You can draw a free body diagram of a launched projectile and identify all the forces that are acting on it. No matter what the object is, after a projectile has been given an initial thrust, if you ignore air resistance, it moves through the air only under the force of gravity. The force of gravity is what causes the object to curve downward in a parabolic flight path. Its path through space is called its trajectory. If you know the force of the initial thrust on the projectile, you can calculate its trajectory. When a projectile is launched at an angle, the initial velocity has a vertical component as well as a horizontal component. If the object is launched upward like a baseball tossed straight up in the air, it rises with slowing speed and reaches the top of its path and descends with increasing speed.
Projectile motion formulas. For these types of problems, we use different types of equations. We have up and down equations and trajectory path equations. For up and down, the first formula is the velocity in the y direction, which equals the velocity in the y direction initially plus the acceleration in y direction multiplied by the time. The second equation is the acceleration in the y direction equaling negative 9.8, or the gravity. The third equation is how high up in the y direction, which equals the distance in the y direction plus the velocity in the y direction initially multiplied by the time, plus the acceleration in the y direction multiplied by the time squared over 2. The fourth equation is the velocity in the x direction, which equals the distance in the x direction divided by the time.
SOHCAHTOA is also used to find the angles of the projectiles.
Our first formula for the trajectory path is x equals velocity in x direction, square root of negative 2y, which is the distance in the y direction, over g, which is 9.8 meters per second. The equation is a distance in y direction equals distance in y direction initially, plus velocity in y direction times final time plus gravity, 9.8 meters per second. Our third equation is dy, velocity in y direction, equals velocity in y direction initially plus gravity, 9.8 meters per second, times final time. Our last equation is velocity in x direction equals x direction over time. A ball is launched at 4.5 meters per second at 66 degrees above the horizontal. What are the maximum height and flight time of the ball? Yi equals 0.0 meters, Vi equals 4.5 meters per second, theta equals 66 degrees, Ay equals negative g, or negative 9.8 meters per second. Now we have to solve for the unknown. We have to find the y component of Vi, find an expression for time, solve for the maximum height, and solve for the time to return to the launching height. First, we find the y component of Vi. We find that it is 4.1 meters per second. Next, we find the expression for time, which we find is 0.42 seconds. Next, we have to solve for maximum height, which we find is 0.86 meters.
We found the maximum height was 0.86 meters, and in order to find the maximum flight time of the ball, you square the original time that we found, which was 0.46 seconds, which squared is 0.84 seconds. Projectile motion is a form of motion in which an object or particle called a projectile is thrown near the Earth's surface and it moves along a curved path under the action of gravity only.